Okay, this video is meant to help with understanding what factoring completely means. Essentially taking a factored form, or a standard form equation, I guess, standard form expression, and completely removing any parts, such as a greatest common factor, as well as splitting up any factors, such as binomials, completely. And what that really means is, if we take a look at the standard form expressions we have on the screen here, in the first one you might notice that 4, 20, and 24 all have a 4 in them. If you divided out a 4, it would divide out evenly. So what we can do is we can take a 4 outside of there. So if I divide 4x to the third by 4, it would actually become x to the third plus, divide by 4 on the 20 is a 5, x squared plus, and again divide 24 by 4 becomes a 6x. Now you might also notice that there's an x in all the parts. So really, if we want to take out the greatest common factor, we want to remove those x's as well. And since the first term has an x to the third, there's an x squared in the middle, but there's only an x to the first, the most x's I could take out of all parts, again, would be x to the first. I can't take more than what's present in each individual term. But that would become an x squared then, plus a 5x plus 6. So as far as the greatest common factor goes, that's what we get. Now, we would need to take a look and see what's left over. What you always want to ask yourself is, can you do more? If x squared plus 5x plus 6 is factorable, which I think it more than likely is, we should be able to make that into two binomials. So again, if that's the case, x squared must have come from x times x. And we want to ask ourselves again, what multiplies to 6 that's also going to add to 5. And I believe 2 and 3 should work. Don't forget to carry that 4x down from the previous step, and we have our final answer then, 4x times x plus 2 times x plus 3. No more can be done to the 4x. X plus 2 doesn't have anything in common between the two, and again, it's not squared anymore, so I can't do anything more there. And same thing with x plus 3. Go ahead and take a second. I'm going to pause the video now, and then I'll fill in the answers. But the other two expressions, go ahead and try those first. Again, start with the greatest common factor, and then ask yourself, once you've removed that, can you do more? Go ahead and pause the video now. Okay, to start with the standard form expression in the upper right here, I noticed that there was a 5 in each part. 5 goes into 5, 25, and 30. So I went ahead and pulled out a 5 out in front here. Sorry, it looks a little messy. The pen is a little tough to write with here. There's an x in each of the parts as well. So we took out an x out in front. Again, divide that out of each piece, and that should leave us with x squared minus 5x minus 6. 5x times each of those pieces would get you right back to the beginning. Then x squared minus 5x minus 6, well, negative 6 times 1 would be negative 6, and negative 6 plus 1 is negative 5. So we can split that into the two binomials, and we've got our 5x out in front. Very similar to the first problem. The one on the bottom, again, I took a look at it. There's no x in both parts, because 36 is all by itself, but 4 does go into both 4 and 36, so I removed that out in front. That's my greatest common factor again, leaving behind an x squared plus 9. Now, remember, we have the formula for the difference of squares. However, there is no formula for the sum of squares. So unfortunately, x squared plus 9 isn't going to be able to be taken apart, so we would just leave our answer there. Again, that's factoring completely. You want to take everything as far apart as you can. Another thing that we're going to be doing is called factoring by grouping. And we've actually done this before, if we use that method to factor when our leading coefficient wasn't a 1 on many quadratics, on many x squared trinomial problems. The main idea of factoring by grouping is that you're going to remove a common binomial. So taking a look at the problem, that x minus 3, again, is a common binomial. It's separated by this plus sign in the middle. So if there's a 4x times x minus 3, and there's a 5 times x minus 3, what we can do is we can remove that x minus 3. That will become one of our factors. Now multiplied, notice no longer added in the middle, it's multiplied by 4x and plus 5. It's just like saying that that x minus 3 would be distributed times the 4x as it is on the left, and then the whole quantity again times the 5 as it is on the right. But that is removing a common binomial. Now, where does that help us? Well, when we're factoring by grouping over here on the right. If I group the first two terms, if it'll let me write here, and I group the second two terms, right? Now I can look at them in parts. Notice again that plus sign in between. It's the same as that plus sign we pointed to over here. X cubed and x to the second, well, there's an x squared in both parts, which would be multiplied by x to give you x cubed, and by 2 to give you 2x squared. Plus, again, carrying down that plus sign, in the second two terms there's a 3 in common, and I can leave behind an x, and again 6 divided by 3 is a 2. Note that x plus 2 and x plus 2 are a common binomial, and x squared plus 3 would be our other binomial. Because x minus 2, I can't do anything more to that. It's x to the first. There's nothing really to break apart there. And x squared is over here, but it's not a difference again, and not a perfect square with the 3. Then there's no more that I can do. Go ahead and try the factoring by grouping that's over here at the left side. X cubed minus 2x squared minus 9x plus 18. I will give you a hint before you get started. When you go to group these, this minus sign in between can be tricky. What probably the best idea to do is make that a plus sign, again, so it matches up again with our other problems, but leave the negative on the 9 before you group. If you leave that inside the parentheses, this will be much easier to do. Go ahead and take a second, factor the first two, the second two, and see if you come up with a common binomial. Pause the video now. Alright, having left that negative inside, that means that in the first two terms we've got an x squared, leaving behind x minus 2, x squared times x squared times negative 2 should distribute well. And because that front number was negative, go ahead and pull a negative 9. Hopefully you notice the 9 in both parts, but we want to take that negative out. So divide by a negative 9 leaves you with x, and 18 divided by negative 9 leaves you with a minus 2. Those minus signs mean that x minus 2 and x minus 2 match up. And so therefore they are our common term down here, and x squared minus 9 would be the other term. Now again, just like factoring completely, we want to take a look and say, is there anything more I can do? X minus 2 is as simplified as it's going to get. However, x squared minus 9, x squared and 9 are perfect squares, and we have the difference of squares then. So we can call this x minus 3, x plus 3. Remember that 3 times negative 3 will get you negative 9, and on the outside 3x, and inside negative 3x, 3x plus negative 3x adds to 0 middle term. There is no middle term up here. So that's a great way to do that. Don't forget to carry your x minus 2 down, and that would be your answer. It can be a little tricky when the common binomial looks almost alike, but notice the order is a little bit backwards. Y minus 5 and 5 minus y are not the same thing. However, if we take 5 minus y and we factor out a negative, similar to what we did over here, that will become a negative 5, and negative y will become a positive y. With a little bit of work then, remember addition we can change the order of, so positive y can be written first, and negative 5 essentially means minus 5. And now y minus 5 matches up with the y minus 5 earlier. So let's take this and we're going to replace our formula here. 2y squared, y minus 5, minus 3 times negative y minus 5 in parentheses there. Again, this is all just multiplied. So really that negative on the outside is multiplied here by that negative 3. You really have 2y squared y minus 5 plus, right, negative 3 times negative 1 here, 3. But now the beauty is we have that common binomial. We've got y minus 5 in both parts, separated by that addition sign, and you've got 2y squared plus 3 left over. I hope that helps. Again, that's where things can get a little bit tricky. Again, if you have any questions, make sure you talk to your teacher. Otherwise, good luck, have a great day, and happy math.